So, welcome to the next class on drying. So, till now, I think we have covered till rate of drying curve, and then we are yet to do the dryers, classification of dryers, and what kind of equipments are used in chapter drying. So, let us start. So, so this is the classification of drying equipment. Drying equipments basically are classified on many other criteria. Like you can also have wet dryers, or you can either provide heat, uh, radiation kind of heat, convection kind of heat. There are many dryers in this chapter, but then the usual classification, the most prominent type of classification is this type of dryer based on the mechanism. Now the first one is your static bed dryer, which is for examples given for this, a tray dryer and freeze dryer. The What is a static bed dryer is very simple. The bed doesn't move. The bed of solids doesn't move. There's only like tray dryer. You place the bed of solids on a tray and let the drying happen. Like freeze dryer, there's no movement in the bed of solids. The word static means there's no movement in the bed of solids. The solids do not move. Right? Advantages for this is attrition is not observed. Attrition is not observed in this particular kind of dryers, and only a fraction of solid particles is directly exposed for this kind of dryers, which is a disadvantage for us. Uh, so the efficiency of drying comes down with this kind of dryers. Now, what is a moving bed dryer? Is a drum dryer. Example for this, the name suggests that your solids are moving in this kind of dryers. So the advantages is the entire material is continuously exposed to the heat source. Attrition is not possible in this. The disadvantages is attrition is not possible in this kind of dryers. Now the next one is your fluidized bed dryer. The bed of solids undergo a fluidized motion. The word fluidized means that your solids are in a suspended motion. They're all suspended in a hot air, high velocity hot air. That kind of motion is called fluidized bed motion. So such kind of motion is observed, then it is called fluidized bed dryer. Advantages for this is solid gas contact is excellent. When all your particles are suspended in this kind of air, what happens is each and every individual particle is exposed to air. So solid gas contact is excellent. Uniform drying happens. One of the best equipments available in any chapter, if you see, fluidized bed dryer or fluid energy mill. We have studied size reduction chapter where you know fluid energy mill, right? There also you see this fluidized motion. So size reduction is efficient. One of the best equipments available, modern and efficient equipments. Attrition of particles takes place in fluidized bed dryer. Now, the last kind of classification is pneumatic dryers, where the best example given can be a spray dryer. Spray dryer also efficient and rapid drying can be seen. Disadvantages, not many disadvantages can be quoted for this pneumatic dryers. There are also other kind of classifications for drying chapter. Batch dryers, continuous dryers. Are they batch dryers or continuous? What is a batch dryer is limited amount of solids can be dried in this kind of equipments. Once drying process completes, you will have to remove. Say for example, you can see tray dryer. Tray dryer in our laboratory can take up to 5 kgs. All the trays will be filled. After this 5 kgs of solids are dried, you will have to stop the equipment, remove it, and then give new feed. So it is not a continuous process. There is an interruption in between. So such kind of dryers are batch dryers. Continuous dryers is rotary drum dryer. Drum dryer is a continuous dryer where continuous movement of solids, and continuously you can collect end product also. So you need not stop the process in such kind of equipments. Now there are semi-batch, semi-continuous dryers also. Based on drying time also, residence time, you can um, classify dryers. So this is the basic classification we generally use: static bed dryers, moving bed dryers, etc. Right. So the next equipment, the first equipment that we are trying to study in this chapter is a tray dryer. Age old, ఎప్పటి నుంచో the dryer which is available from long time is this tray dryer. So this is the equipment. Tray dryer is there in our laboratory. You can have a look at it. Now tray drying is a batch process, and it is used to dry materials that are liquids or wet, uh, cake kind of thing. And tray drying works well for materials that require gentle processing, or they cannot be atomized in airstream due to viscosity. Such kind of materials, you can generally use a tray dryer. What is the principle here is very simple. It is forced convection. It is forced convection and conduction. Where conduction takes place is your trays have to get heated by the hot air that you're passing. That is conduction. Solid metal is getting heated up, which is conduction. And then forced convection is there's a fan inside which forces the air, hot air, to get circulated in whole of this equipment. So that is forced convection. So hot air is continuously circulated, and air from outside is taken. There are heaters here inside the walls of the tray dryers, which heat up the air, and then there are knobs outside to adjust the temperature. The hot air will continuously pass over the solids. Now, say, let me just show you. Say this is my tray, and then I have placed. Always remember, solids have to be evenly spread, and the diameter just has to be 2.5 or maximum of 5 centimeters, right? And then hot air will pass over this trace and will take up the moisture that is present and will dry the material. So in a single pass of air, most of the moisture may not be removed, so it is not that efficient. So the principle again is forced convection takes place. What is forced convection is there is a fan inside which will force the hot air to pass over the trace, which takes place to remove the moisture solids from the solids placed in the trace. Simultaneously, moist air is removed partially. There's an exhaust which will remove the moist air partially. Construction, it can be, tray dryer can be electrically or steam heated. It consists of any number of trays that varies with the customer requirement. Industries have generally have room sized tray dryers. We generally have 4 to 6 trays. It is fabricated out of rigid iron frame with double walled panels. The side panels of the tray dryer are generally insulated to prevent loss of heat. And a control panel is fixed in the front of the oven to facilitate easy operation. There are two knobs generally, one to show the temperature, and the other to show to control the air circulation and so on. Now, it has large functional space in between, and it can resist temperatures up to 300 degrees centigrade. Now, working is the material to be dried is placed on the trays. Heat in the dryer is produced by heater along a side. There will be heaters. It can be at the base or it can be at the sides. Right? And heat in the dryer is produced by heater. Other than hot air generated by oven, other method is to employ radiator coils that use steam for heat circulation. And during the heating process, the material is spread out on the trays. Heated air is directed to flow in a circulation form. It flows over the material in the trays, and trays can have solid or perforated or wire mesh base. Right? And the fresh air is combined with heated air in a fixed proportion for an efficient performance. in between the tray dryers take air from outside, and the fresh air is combined with hot air for efficient performances. Advantages, batch mode, it operates on batch mode. So each batch can be handled separately, and it's simple to use. It consumes less energy, and it is available in single chamber tray dryer, multi chamber, various sizes and uh, capacities can be fabricated. And disadvantages, it comes over dry అవుతాయి. Sometimes the contents in your tray dryer tend to get over dry. Operation is very long. Sometimes if you have big equipments, it will take almost for 24 to 72 hours also. So it is not suitable for large scale production, and thermolabile drugs or substances cannot be dried. This is about tray dryer. The next equipment that we are trying to study is a drum dryer, where the drum dryer also has been used since long time for drying sheets of paper or cloth, or more recently it is used to dry liquids and pastes. And now drum dryers in general, they have various types of drum dryers, single drum, vacuum single drum. Inside you can have vacuum, that you will study in this. We have already filtration equipment. You have a perforated mesh kind of surface on the drum, and inside you can place a vacuum, right? So single drum can be there, vacuum drum can be there, or double drum dryers are also there. Now coming back to the principle, there is a heated hollow metal drum. This drum is hollow, first thing, and this is shown in a cross sectional uh, kind. If you want to imagine it in 3D, you can imagine a road roller's a drum that is there. Heated hollow metal drum rotates on its longitudinal axis, which is partially dipped, not fully dipped. It is partially dipped in the solution to be dried. Now this solution is carried as a film on the surface of the dryer till here, and then during this journey from here till it completes one revolution, this drum, all the solids that are, all the liquid that is there on the solid surface of the drum will get dried up. Why does it get dried up? Where is the heat coming from? Is it is hollow. The first thing that I told you is a hollow metal drum, and inside you have heat, steam. Now the surface is so hot that as soon as it comes in contact with the liquid, it turns into solid. The moist air leaves as a vapor, and there's a thin film formed on the surface of the drum. Till here it comes, and then there is a scraper here, which scrapes off the material from the surface of the drum. After almost one revolution, the remaining dried material is removed by a knife or doctor's knife. There's a scraper or doctor's knife here. This is the principle, very simple. As the drum rotates, as it completes each revolution, the paste that is in contact with the surface of the drum gets heated up and dried. Again, the same problem comes here. Thermolabile substances cannot be operated in this kind of equipment, right? And then construction, drum dryer is a moving bed dryer. That means your particles move. The unit is constructed from cast iron and stainless steel. Drums are engineered with hard chrome plating or chrome plated over nickel to ensure maximum heat transfer. And the drums are hollow. Almost you can expect diameter can be 0.6 to 3 meters in diameter, and length can be length can be 0.6 to 4 meters in length. Now, inside you can have steam or heating coils, which can be used inside the drum for heat generation. Heat is transferred by conduction. Generally, the metal drum, I told you it is a solid metal, so it gets heated up by conduction, and drum is rotated at 1 to 10 RPM. That means per minute, it will only take one revolution. That means you can imagine the speed of rotation of drum. So this is about the construction. And then working is the robust construction of drum dryers. Uh, they they are still in use today only because of the construction of drum dryer. And then the steam that is there inside heats up the metal surface. The surface of the drum is very hot due to the steam that is there inside. And this, as it is partially dipped in the solution, so it will, as soon as it starts to revolve, it will take a thin layer of liquid or paste or film on the surface of the drum. Now, as it completes one revolution, what happens is, due to the heat that is there and heat transfer that happens due to conduction, the film gets heated up and it gets dried up. And there's a knife here which scrapes off the material. Again, it takes a few ml of paste and it gets heated up and dried. So this is a continuous process. It is a moving bed dryer. The speed of the rotation of drum can be controlled based on the dryness that you want and thickness of the film that is obtained. So there are very many variable parameters that can be controlled as per the requirement. Now coming to advantages, it gives a very rapid drying. That means one few seconds of drying, mass transfer rate is higher, entire material is continuously exposed to uniform heat. So equipment is compact. It can have vacuum facilities, like I told you, inside in the hollow metal drum, you can also have a vacuum, which even gives you more efficiency. And disadvantages are thermolabile substances, low concentration solutions, suspensions of low viscosity cannot be operated. Second thing is skill is required. Skilled labor is required to control the feed rate, film thickness, speed of rotation, temperature, etc. There are many variable parameters that I told you.